lecturer Dr. Azli bin Nawawi. So today we are going to present our group project, which is Backgrinders Design Analysis. Before we start our presentation, I will introduce to you all of my group member. My name is Izul Hafiz bin Zulkifli. Next group member is Muhammad Alif bin Muhammad Nur Zafarullah, Muhammad Amirul Mukminin bin Muhammad Ali, Muhammad Ruslan bin Muhammad Zamir, and Muhammad Syafiq bin Amiruddin. So for this project, it was aimed to design a machine contains the elements which was laid out by the lecturer, which are bearings, gears, shaft, and permanent or non-permanent joints. This project required to design a product to solve any problem that occur in the real world applications. So this project requires students to draw the parts, assemble the parts, and apply the finite element analysis on every critical parts. This project contains drawing of the machine, analysis, and report of the analysis. So for the literature review, the software we used is SolidWorks CAD software. SolidWorks is a solid modeling software that allows the students to design products in the dimensions. The technique is generally to sketch the 2D profiles, then use the methods like extrude and lofting to produce the solid shape. The SolidWorks software is an easy to use parametric design modular, meaning students can easily edit the design at any stage in the design process. Next is finite element analysis. The finite element analysis is the simulation of any given physical phenomenon using the numerical technique called the finite element method. So engineers use it to reduce the number of physical prototypes and experiments and better components in their design phase to develop better products. Next is the finite element analysis in SolidWorks. Finite element analysis is more accessible and simpler than ever. So SolidWorks package include a great finite element analysis tools that are very user friendly. Next, I will pass to my teammate Muhammad Alif.
Okay, thank you to my friend Izul Hafiz for his presentation earlier. Okay, next I'm going to proceed this presentation with the methodology parts. Okay, for the methodology, first we have to start the process, and then next we are going to decide the title of the project. Okay, after deciding the title of the project, we proceed with design on the machine or equipment. Okay, after settle for the design, next we are going to do the FEA analysis, which is finite element analysis. After all the analysis is done, and then we are going to proceed to the question: does the design fail? Okay, in this part we have to we need to separate it into two parts, which is yes or no. If yes, we have to design the machine or the equipment. Okay, if no, we need to reduce the dimension or weight of the material. Okay, after that we proceed with the FEA analysis again. So we are going to do this FEA analysis 2 times or more, and then back to the question: does the design fail? Okay, if the design fail, if yes, then we have to store the data of the design, and then we are going to repeat the process, which is to reduce the dimension or weight of the material, and then we need to proceed with the FEA analysis, finite element analysis. Okay, if no, then we need to use the last successful data design, the last one, which is the probably or mostly the right one for the data, and then proceed with the next process. And we have to separate into 3 parts. The first one is to produce the presentation slide. The second one, produce the FEA report using SolidWorks, and the last one is to produce the design of the drawing. Okay, for the producing the FEA report using SolidWorks, we need to proceed to submit the final report and then end of the task. next, for the methodology of the FEA analysis for the flowchart. Okay, first start, and then the second one, for the process, we need to create the 3D CAD model, and then after that proceed with the clean up the 3D CAD model, and after that save the 3D CAD geometry in neutral format, and then save the 3D CAD geometry in neutral format. Next, define the material properties for the project, and then solve the problem. And last one, post processing, and then stop. That's all. Thank you.
Okay, thank you Alif for the presentation. Okay, I'm going to continue on the methodology. Okay, for the material construction, we choose alloy steel. Okay, a little bit of alloy steel. Properties of alloy steel, as you can see, that alloy steel is a stabilizing austentite. Elements like nickel, manganese, cobalt, and copper increase the temperature between which austenite exists. Okay, the stabilizing ferrite, molybdenum, vanadium, aluminum, and silicon, and may have effect on the lowering carbon solubility. Okay, about our project procedure. Okay, our project first we produce the part for the back grinder by using SolidWorks. Next, we assemble those parts by using the assembly feature. Then we make sure the design is completely assembled for the simulation process. After that, run the simulation by using the SolidWorks Adds in Simulation feature. Okay, before we run the simulation, we must make sure the simulation add-ins are loaded completely. Okay, after that, we carry out the FEA analysis. First, we need to choose the new study icon. Okay, to continue this presentation, I will pass to my friend Muhammad Roslan. Okay, thank you.
Okay, and thank you Amirul Mukminin. So next, I will continue on the project procedure. Okay, then select the type of testing which is going to apply on the bed grinder. So our testing is about static testing. So next is assign the material to the design, which is alloy steel. After that, assign the contact for design, that we have to click on all the parts in the model. So after that, we assign the fixed point for the design. After that, assign the value of force exerted to the design, which is 1000 Newton or 100 kilogram. Run the analysis by clicking the run and mesh button. After that, after the simulation is complete, obtain the required result by accessing the desired subfolder. Okay, next is result and analysis. Based on the analysis, the target was achieved as the assembly part can withstand the load and it can support the load of 1000 Newton. For the finite element analysis of the part, not all the parts were tested for 100,000 Newton. Just assemble the critical parts and test it with the static force, which is about 100 kg or 1000 Newton. Choosing a proper material plays an important role in finite element analysis. Due to that, a specific material also playing part in this finite element analysis. Okay, that's all for me. Next, I will pass to Muhammad Shafiq. Thank you.
Okay, thank you Muhammad Roslan. And next I continue with the conclusion. For the conclusion, design which differ from material and manufacturing process to identify the best design of the analysis so as to discover the material and assembly procedure of the item. Static analysis was the important analysis among the FEA analysis, based on the objective to achieve the target to create a machine which is able to withstand a load of 1000 Newton or 101.97 kg was successfully achieved. All the value from the result has compared with the FEA analysis. The objective of achieve the target, which is to withstand the load of 1000 Newton, was successfully. For the recommendation, first, the design product dimension based on the suggestion given DFA by the material and manufacturing process based on the DFN analysis can be rebuilt. This will make sure the material is even more perfect and could withstand the load of more than the fit one. Second, the proper dimensions scale need to be given for future analysis. And for the last recommendation is implement the comprehensive coherent product realization process. That's all for our group. Thank you.